Before we write any SQL, let's understand where data lives. Imagine a database not as a library, but as a massive, perfectly organized digital filing cabinet. Its sole purpose is to store and protect information in a structured way, making it incredibly fast to find anything you need. If the database is our filing cabinet, then the drawers inside are called tables. Each table is like a dedicated folder for one specific category of information. For example, we might have one table for employees, another for products, and a third for sales. You'd never mix employee data with product information. Let's look inside one of these folders. A table is a grid, just like a spreadsheet, made of columns and rows. The columns are the vertical headers that define what kind of information we're storing, like first name or salary. Each horizontal row represents a single, complete record, like one specific employee. Throughout this video, we'll be working with a sample employees table. It has columns like employee ID, first name, last name, job title, and department. Getting familiar with this structure now will make our upcoming queries much easier to understand. This is the data we'll be asking questions about. So, we have our data neatly organized in the employees table. How do we ask the database to show it to us? We use a query. A query is simply a question written in a language the database understands, SQL. The most common query starts with the command select. The most basic SQL query has two essential parts. First, the select keyword, which tells the database what columns you want to see. Second, the from keyword, which specifies which table you want to get those columns from. Together, they form the core of every data retrieval query. Let's start with the simplest possible question. Show me everything in the employees table. To do this, we use a special character in place of a column list, the asterisk. In SQL, the asterisk star is a wildcard that means all columns. It's a powerful shortcut. Now, let's combine these parts to write our very first query. To select all columns from our employees table, the full command is select asterisk from employees. Notice the semicolon at the end. It's like a period in a sentence, marking the end of our SQL command. When the database executes that query, it gives us back a result set. In this case, the result set is a complete copy of the employees table. It has the exact same columns and contains every single row of data. We've successfully retrieved our first data set. While select star is great for exploring, in the real world, it's often inefficient. Sending all data across a network can be slow, and you usually only need a few specific pieces of information. This is where selecting columns by name becomes essential for writing professional, efficient queries. To select specific columns, we simply replace the asterisk with a comma-separated list of the column names we want. The syntax is select column 1, comma 2 from table name. The order you list the columns in is the order they will appear in your result. Let's write a query to get just the first name, last name, and job title for all our employees. The command would be select first name, last name, job title from employees. We are explicitly telling the database to ignore the employee ID, department, and salary for this request. And here is the result. As you can see, the output table contains only the three columns we asked for: first name, last name, and job title. The database has delivered a clean, focused result set that's much easier to work with than the full table. So far, we've selected columns for all the rows in our table. But what if we don't want all employees? What if we only want employees from the sales department? To filter our rows, we need to add a new and incredibly powerful clause to our query. To filter rows, we introduce the where clause. The where clause is added after the from clause and specifies a condition that each row must meet to be included in the result. The query's logic becomes, first, pick the table, then filter the rows based on a condition. Let's create a condition. To find all employees in the sales department, our condition would be where department equals sales. When filtering on text data, also known as strings, you must enclose the value in single quotes. This is a critical piece of SQL syntax. Now let's build a full query to find everyone in sales. We'll ask for all columns for now. The query is select all from employees, where department equals sales. The database will now scan the employees table and only return the rows where the department column has the exact value sales. And here is our filtered result set. Notice that only the employees from the sales department are included. All other rows from the original table have been filtered out, giving us a precise answer to our question. We have successfully retrieved a specific subset of our data. Now for the ultimate combination. We can be precise with both our columns and our rows in the same query. Let's say we need the first name and salary, but only for employees in the marketing department. We can easily combine our skills to do this. Here is the final query that accomplishes this goal. Select first name, salary from employees where department equals marketing. This is a perfect example of a professional, efficient query. It asks a very specific question and requests only the data needed to answer it. And here is the final, precise result. The database has given us a small table with just the first names and salaries of the marketing team. This is the power of SQL. Starting with a huge table of data and refining it down to the exact answer you need. Let's quickly recap what you've accomplished. You've learned about the structure of databases, how to retrieve all data with select star, how to specify columns for precision, and how to filter for specific records using the where clause with both text and numbers. These are the absolute cornerstones of SQL. Congratulations on mastering the fundamentals of the select statement. Practice is key, so try writing your own queries on our sample data. In our next video, we'll expand on the where clause with more operators and learn how to sort your results with order by. Thanks for watching.